Hi everyone, this is a small discussion on how to find inverse of a function. Before we learn how to find the inverse of a function and what are its properties, let's quickly visualize what exactly the graph of how exactly the graph of inverse function looks like. So on the right hand side you can see the blue graph is a linear graph. Equation of this is a line, right? So I'm going to move this red dot and let's see how does the graph of the inverse of this function appear. So if you see, the graph of the linear is coming out to be linear. That's very clear because the equation of the line is the general equation of line is y is equal to mx plus c. And what does this dotted line, if you can see, the green graph and the blue graph are intersecting at a point, right? And the coordinates of that point seem to be 2 units to the right, to the left, and 2 units down, right? And they both look like they both are symmetrical about the dotted line. So that means inverse function, the first property, inverse function and the original function, they are symmetrical about the y is equal to x, because that dotted line is passing through x is equal to all the points where x is equals to y. So they are the symmetrical about. So the first property is that they are symmetrical about line y is equal to n, and that is why they are having intersection at this point, if you can see, right? So second property, if they are intersecting, and because x is -2 and the y is also -2 at this point, then that means the point of the intersection means both the function will give me the same value at that particular point, or I can say that x will be is equal to y at that particular point, right? Let's see whether this behavior is same for the next graph. So this is your exponential curve, right? Increasing curve, exponential increasing. And if you see, this seems to be 3 raised to power x, right? So when I'm going to move, and as of now its domain is, now we have to look at the domain and the range relation. So here I'm going to write f and f inverse and domain. So as of now my domain of f is -infinity to infinity, and the range is, it is on the upper half of the plane, so the range is simply 0 to infinity. And we are able to see over here we have an asymptotic behavior. So once I start moving the point, the red dot, you see the graph, the green dot is moving up, and now you can see the whole curve green. And as I move further, the graph exponentially increases, the green graph also increases, but the both are still mirror images of each other because they have to be symmetrical about y is equal to x. But if you see, these graphs are not intersecting, right? And that's why I said if they are intersecting, then there is, at that point both the functions have one value equal, right? Now we can see this section was the horizontal asymptotic section, and that section is equivalent to the vertically down section of the green curve. So the another very important property of the f and f inverse is, if there is horizontal asymptote in f, that becomes vertical asymptote in f inverse. And that makes sense because we are inverse is the symmetrical graph about y is equal to x. It means the very core principle that the inverse function means you have to interchange x and y. So now if we look at the domain and the range, we come back to the domain and the range. The green graph has the domain 0 to infinity, and the green graph has the range, it is downward and it is the upward also, so it has the range as all real numbers. And now you can see the domain and interchange, domain and range have interchange. That's all because of the property, one single property, that they both interchange at x and y, and hence these are not intersecting, and the horizontal asymptote of f resonates to this. So with these property we can always sketch the any function, inverse of any function, just by seeing its mirror image in the y is equal to x line. So if I give you this line, I would really suggest if you sketch the y is equal to x line for this cubic function and try to sketch the inverse graph of the inverse on your own. Thank you. If you have any doubts, then please leave in comments.